Okay, welcome to lesson 2.10.8. This is writing quadratics in vertex form. So our objectives are to use the vertex and a point that it passes through to write a quadratic in vertex form. So before we begin, let's review. Vertex form looks like this, where our vertex is h comma k, and you can see it here in this graph. This is vertex form, and our vertex is h comma k. A represents our rate of change, and we know it's a quadratic equation because it has a power of 2. So let's go ahead and practice, seeing if we can write an actual equation given just the vertex and a point that the quadratic might pass through. Okay, example 1. Here we have a quadratic with a vertex of 3, 5 and passes through the point 7, 12. So if I look back on my first slide, what that means is that somewhere, so let's say I went out 7 and up 12, that point is actually on my quadratic. It passes through that point. Okay, so first things first, I have the quadratic equation here in vertex form, so let's fill in what we know. We know the vertex, so if I write it with the vertex, I would have a y equals a. I don't know that. And then remember that this minus h part is always the opposite. So if I have a plus 3, then it really was a minus 3 inside the parentheses. And then on the outside, plus k, k is 5. So the only thing tricky about plugging in the vertex is just remembering that your x value is always going to be the opposite. If this had been a minus 3, then this would be x plus 3. Okay, well, I'm really close to writing this in vertex form, right? I have everything filled in except for my a value. I don't know my a value. But I do have this point here, this point 7, 12, and I can do something with that to help me find this a value. You did something similar to this when you would solve for b in y equals mx plus b. If you knew the slope m, and you had a point that you could plug in for x and y, you could find b. And this is really the same idea. We can find a because we have this point 7, 12 that we can plug in for x and y in our equation. So let's go ahead and plug that in. So I'm going to replace the y with the 12. I still don't know a. That's what I'm trying to find. And I can replace the x with the 7 minus 3 squared plus 5. So what I need to do now is simplify all this in order to solve for a. So what I'm going to do is I'm going to do my parentheses first. So be very careful of your order of operations. I have a on the outside. I can do 7 minus 3, which is 4. I'm doing that first before I do anything else. The next thing after parentheses is our exponents, and I do have an exponent, so I can take 4 and raise it to the second power. That will give me 16. 4 times 4 is 16. Okay, so now I'm in a place that's comfortable, something I'm familiar with. Now I will go ahead and do my addition and subtraction and move that over. Minus 5 because I have nothing left to multiply or divide. 12 minus 5 is 7, and then I'll go ahead and write this as 16a, and this is gone. So here's my equation so far. Now all I need to do is divide both sides by 16, and now I know a. A is going to be 7 over 16. Okay, but don't stop there because now we have all the components for writing our final quadratic in vertex form, but we haven't actually written it completely yet. We almost did up here in this first writing, but we were missing the a. So let's go ahead and write the final answer. So that would be y equals, well, now we know a is 7 over 16. That's our rate of change. And then inside the parentheses, we know that our vertex was a 3, 5, so we would have plus 5 on the end. And this is our final answer, and this is how we would write this. All right, let's do one more practice, and then you guys will try it on your own. All right, we have the same situation. We want to write an equation in vertex form for a parabola. We know that a parabola is a quadratic with the vertex of -6, -4, and is going to pass through the point -2, 12. Okay, so we're going to proceed as we did last time. We'll go ahead and write the equation out. Given our vertex, we'll plug that in. So we have y is equal to a, we don't know that, x. Now it's x minus a negative, so that's going to end up being x plus 6. And remember, this always ends up being opposite, which it is, and then minus 4 on the end. Okay, so we're almost there. This is very close. I just need to find my a value. And in order to do that, I can plug in this point, -2, 12, in for x and y. So I'll go ahead and replace y with the 12. I'll replace x with the -2, square all that, and minus 4. And now I just need to simplify. So again, remembering your order of operations, be very careful. We'll do our parentheses first. So we have a times -2 plus 6 is 4. Then I can do my exponents. So 4 times 4, or 4 squared, is 16. And now I'm going to go ahead and rewrite it as 16a, makes a little more sense, minus 4. Okay, now we're in a form that is familiar, so I'll go ahead and add the 4 to both sides. I will get 16 on this side and 16a on this side. Now to solve for a, I just need to divide both sides by 16, and I get a equal to 1. Okay, let's go ahead and write our final equation. So our final equation is going to be y equals, a is just 1, so we can put a 1 there or we can leave it blank. It would be understood to be 1. And then we have x plus 6 squared minus 4. And that would be our final answer. That would be our quadratic in vertex form that we wrote given a vertex and a point that it passes through. And that concludes our 2 examples on how to write quadratics in vertex form. So go ahead and try the practice on your own.